For 7.3 part 2, we're going to talk about expanding and condensing logarithms. Let's start with expanding. And to expand means to basically kind of take something and make it bigger. And that's what we're doing. We're taking one single logarithmic function where maybe the thing you're taking the log of is kind of complicated, and we are expanding it. We're breaking it apart into two or more logs, but the benefit is that each one is much more simple, the thing you're taking the log of. And there are certain problems that you'll want to do that on. I'll talk about that in just a sec. But basically, this is what we call expanding. And we're going to use those same three properties from part 1 of our notes. Here they are again. This is our multiplying, dividing, and exponent rule for logarithms. And basically, if you take any of these and you take this part here on the left and change it into the right, that's what we call expanding. Now what you notice here is it's kind of what I mentioned a minute ago. I said over here you're taking the log of something that's kind of complicated, and we're breaking it into two different very simple logs. Now one example of when expanding is good to use is like when we get to chapter 8 and we start doing derivatives. If I ask you guys to take the derivative of the log base b of u times v, it's actually a very complicated problem. You have to do the logarithm first, which we haven't even learned yet. Then for the u times v, you have to do a chain rule and a product rule. And it gets kind of messy. But if you expand first and break it into two simple logs, it ends up being a very easy derivative to take. So once we get to chapter 8, this expanding process is going to be very useful. But for right now, we just want to practice how to do it. So here are the steps for expanding. To expand, if you're just asked in a problem like in tonight's homework, expand this logarithm. What it means is expand it as much as you can. Keep splitting it and splitting it and splitting it until you can't anymore. Until every single log is as simple as possible. Now, the way you'll know you're done is because each log can't be split anymore. So you'll only have log of a single variable, like log of x or log of y, or possibly a number, log of 2, log of 10. But if you have anything extra in there, if you have log of 2x, that's not done, that can be split. If you have log of x squared, that exponent can be taken out. So we want single things only, just a log of one single simple thing only. We want the exponent property to come last, and I'll show you why in an example. Basically, if you have an exponent on one thing, you need to split it and take the exponent out. And then also remember, there's no splitting property for addition or subtraction. So I gave you an example here. I said if you have the log base 2 of x plus 4, that's finished. That's as simple as it can be. And a common mistake is people try to break that up. They'll go, okay, so that's the log base 2 of x plus the log base 2 of 4. And that's not right. We don't have an expanding property for adding or subtracting. So what you see right here, this is finished. Leave that alone. That cannot be split any more than it already is. So let's do an example. And I'm actually going to do this first kind of the straightforward one step at a time way, and then we'll talk about a little bit of a shortcut for it. But what I see here first, it says expand the log base 3 of 4x squared over 3y, and I see that u over v property. I see that like this is my u, this is my v, so I'm going to use the log of u over v property. What that means is it's going to be, now first of all, whenever you do any of this, the base never changes. So as I start expanding this, every single log will be base 3. So I'm going to use my u over v property and make it the log base 3 of the top, 4x squared, minus the log base 3 of the bottom, which is 3y. And let me put these in parentheses just to make sure it's real clear what we're doing. Okay, now each of those is a multiplying. It's a u times v. So like the first one can be split up into the log base 3 of 4 plus the log base 3 of x squared. So my 4 and my x squared were my u times v. I split it up and added those two things. Then we have minus, and I'm going to put some brackets in here, and I'll talk about that in a second too. Let's do the same thing. That's my u times v again. So I have the log base 3 of 3 plus the log base 3 of y. Now, it's important that you have the brackets in there because what's happening here is you are subtracting both of those. If I don't have the brackets, then what it looks like is it's a plus log base 3y at the end, and it should actually end up being a minus because we are subtracting both of those. Remember, we're subtracting the whole log base 3 of 3y. If I split it up, we're subtracting all of them. So what I really have here, I have minus log base 3 of 3 minus log base 3 of y. And see, you would have had a plus on that last one if you didn't think to put those brackets in there. So we're almost finished. There's one property left. It's the exponent property. So that exponent property says on only the second terms. Log base 3 of 4 is done. We can't do anything with that. This 2 can be brought out front. So we'll have the log base 3 of 4. That one's finished. We have 2 times the log base 3 of x. That one's finished. See how I use that third property where you can drag an exponent out front and make it a coefficient. There's one more thing we can do. The log base 3 of 3 is 1. So I'm actually just going to make this minus 1. Because remember, the log base 3 of 3 is really asking you 3 to what power equals 3, and that's 1. And finally, the log base 3 of y is finished. So this is my final answer here. And if you check each term and just make sure each one is as simplified as possible, then you'll know you're done. Log base 3 of 4, can't do anything with that. 2 times log base 3 of x. X is done. The one that turned into a 1 is definitely done. And log base 3 of y is done. So that is expanded as much as possible. Now, before I move on, I want to go back to the first step on this question. Remember I said the exponent rule has to come last? A lot of people, and this would be a mistake, a lot of people on this very first step, they see that 2, and they go, oh, I'm going to bring it out here and make that 2 times log base 3 of 4x. Now the problem is the 2 is only attached to the x, not the 4. So it needs to come out here. If you're bringing the 2 out now, what you're essentially saying is the 4 was also squared. So you're kind of adding an extra factor in there that wasn't there. So don't ever pull that exponent out if there's more than one piece within the log. Separate them first. That's when the exponent comes out. Now the other thing I want to do is show you kind of a shortcut on this because there's actually a much easier way to do this question. So we'll go back and we'll rework out this question in just a second, but think of it this way. Instead of right at the beginning, I said, okay, let's do u over v. So I had the 4x squared and the 3y. And I said, okay, so I had log of 4x squared, log of 3y, one minus the other. What you can do instead of thinking of it as 2 parts, think of it for that question as 4 parts. You just go, okay, I got on top, I had a 4 and an x squared. On bottom, I had a 3 and a y. If I think of that as 4 separate parts instead of just 2, you can actually skip almost straight to the end of the question. So what I said is, for every number or variable on the top, those are basically your multiplied together logs, and you make a positive log for each one of those. Now for each log in the denominator, separately, those are the ones that are being divided, so you subtract or you make a negative log for each one of those. So let's go back and look at this question, and I'll show you can actually do it much easier. Here's the same example. Instead of thinking of it as 2 parts, like a 4x squared and a 3y, I'm going to say I'm taking the log base 3 of all of this, but I have a 4 on top and an x squared on top. I have a 3 on bottom and a y on bottom. So I can skip straight to the point. I can say, so each one from the top, those are all being multiplied together. Those become positive logs that are added together. So I have the log base 3 of 4 plus the log base 3 of x squared. Then on the bottom, you have the 3 and the y. Those are the numbers that are being divided. Well, our rule for dividing is you subtract off those logs. So I have minus log base 3 of 3 and minus log base 3 of y. Now, if you notice, we are at the second to last step of the question that we just did without doing all the work ahead of time. All I have to do to finish out this question now is bring this 2 out front and evaluate that one. And you get your final answer. Your final answer would be, we'll leave the log base 3 of 4, we'll bring that 2 out front, we'll turn that into a 1 because it's log base 3 of 3, and we'll leave the log base 3 of y. Exact same answer, much quicker and easier way to get there. So you're welcome to use that when you're expanding. You don't have to do it one step at a time. It actually gets much more confusing when you do it that way. If you look at this expanding part and get used to thinking of each piece of the equation as its own part and breaking it up into 3 or 4 or 10 pieces right off the bat, instead of doing 2 at a time, it's actually a lot easier. All right, so that brings us to condensing. And what it is the exact opposite. So in expanding, you start with one log that's kind of messy, and you break it up into a whole bunch of simple ones. In condensing, we do literally the exact opposite. So you have maybe 2 or 3 or more logarithms, and you want to combine it into one. Now, I gave you an example of when that would be good for expanding. I said if you're taking derivatives, expanding is good because it's easier. If you're solving log equations, condensing is better. If you can take a whole bunch of logs and combine it into one, you'll see next section it's much easier to solve that equation. So it just depends on what you're doing. Sometimes expanding makes a question easier. Sometimes condensing makes a question easier. So we want to make sure we know how to do both of them. Basically, it means to just exactly what we said. Take many different logs and combine them into as few as possible. Now, number one, you can only combine logs with the same base. And that's why I said, if you think back to the last slide just a second ago, I didn't say combine it into one. I said combine it into as few as possible. We would like to combine it all into one. If you have the same base everywhere in your problem, then yeah, you're going to combine it into one. But if you have a log base 2 here and a log base 7 over here, those can't be combined. Those need to be left separate. We're going to use the exact same 3 properties as we did from expanding, but we're going in the opposite order. And just remember to follow order of operations on this one. Basically focus on parentheses. If you have a question with some parentheses in there, that always has to go first. And that's just a math rule. That's not specific for this question. So here's our same 3 properties again, but what I wanted to do is just mention that we're going opposite. So like when you're condensing, you might have 2 different logs with a base b, and you're going this direction instead. So each one of these, we're going backwards. Or what we might do is we would essentially, like for that last one, we would be taking a coefficient and putting it back in as an exponent instead of backwards. So let's go ahead and finish our notes today with an example. We want to condense this as much as possible. And when I see a condensing problem, the very first thing I do is check all the bases. And I notice I have log base 7, log base 7, log base 7. That means that this can all be condensed into one single log. So your final answer should be log base 7 of one thing. And that thing might be kind of messy. There might be a lot in it. But you should only have one single log in your answer. We can combine this all into one single log base 7. All right, now one of the hints I gave you was when you see parentheses, you have to take care of those first. So what I would do to get rid of the parentheses is distribute that 2. I'm going to take that 2 and I'm going to multiply it to the coefficients here. And that would give me 3 log base 7 of x, we'll leave that part, plus, if I distribute the 2, I will have 2 log base 7 of y, and then I will have minus 4 log base 7 of 3. So I'm not multiplying the number inside the log. When I distribute the 2, I don't multiply it times the y or the 3. I'm multiplying it to the number in front of the log function, the coefficient. All right, now we're ready to start condensing. Step 1 is we want to get rid of any coefficients. We want to take those, take like this 3 here, put it back in as an exponent. Take this 2, put it back in as an exponent. Take this 4, put it back in as an exponent. And that would give me log base 7 of x cubed plus log base 7 of y squared minus log base 7 of 3 to the 4th power. Now, once we've gotten rid of all the extra stuff, we got rid of the parentheses, we got rid of the coefficients, we just have, now what I notice here is every single one of these just starts with log base 7. Log base 7 of something, log base 7 of something, log base 7 of something. No extra stuff. No coefficients or anything or parentheses, anything like that. Once you get to that point, you're ready to answer the question. Our question is going to have one single log base 7, and I'm going to use that shortcut but backwards. I'm going to make a fraction here, and I'm going to say for any positive log or any log that's being added, that part goes on top. So like I start with a positive log base 7 of x cubed, so I'm going to put the x cubed on top. And then I have plus log base 7 of y squared, so the y squared also goes on top. Then minus, and anything that's being subtracted, that one goes on the bottom. So I would put my 3 to the 4th power on the bottom. And you can leave it as 3 to the 4th is 81. So if you wrote 81, of course that's fine, but you're also welcome to leave it as 3 to the 4th power. Either one is fine. But that's our final answer. That's condensing. And you know, with this example on the board, you can see we're literally working the exact same question forwards or backwards. If I gave you this question to start, if I give you the answer, the green one, to start and asked you to expand it, you would basically be working your way back up the question like this. So expanding and condensing are opposites. Make sure you know how to do both. I gave you an example, one of each, where it's good to know how to do each one. When we get to solving trig equations next section, you're going to want to do condensing for that. When we go to taking derivatives in chapter 8, you're going to want to do expanding for that. So you definitely want to know how to do both of these.